topic for today is algebraic expressions and equations. So what we are going to discuss is everything that we need to know about uh, algebra. Then we have variables, constant terms, like terms, unlike terms. So these are the stuffs that we are going to discuss. The difference between expressions and equations, and finally we have some questions to go through. So that we'll look into towards the end. Okay, before we start this topic, can anyone tell me what is the meaning of algebra?
Sir, it means to represent the values in variables.
Yeah, very good. So, algebra is basically the branch of mathematics that deals with numbers that are not known or unknown. Say, for example, if I ask you to think about a number, right? And I'll say that whatever number you think of, I'll just multiply that number by 5, right? So you know the number that you're going to think of, but I'm not sure what number is in your mind. So I'll say, I'll use this letter or symbol x to represent what number you are thinking, right? So you may be thinking of the number 2, you may be thinking of the number 3, 4, 5, whatever, right? So I don't know, so I use a variable to represent this, right? So whatever I don't know, I use a variable. So whatever number I'm not aware of, I'll use letters to represent that number. So the branch of mathematics that deals with numbers which are unknown is known as algebra. Okay, and why do we need algebra?
Sir, because in many cases we don't know the values which we need. So to find out the value which is not known, we need to make equation of algebra.
Yeah, very good again. So algebra that we use, I mean, it has various applications in our day-to-day lives. For example, if you want to compare, right, if you want to compute the perimeter of a rectangle, so it is 2 times length plus breadth, right? Area of a rectangle is length into breadth. Why do we represent the length and breadth as L and B? Because we don't know. We can have different rectangles, we can have different squares, right? So based on what the length of the square is or what the length and breadth of the rectangle is, this is going to change. So that is why we use algebra in order to represent those numbers. Another application is, say, if you want to say, if I say something like this, 5 years ago my age will be 28. So what is my age today? So using algebra you can find my age, right? So these are some of the applications of algebra in our daily life. Okay, expressions and equations. So these are two different things, right? So people often confuse, students often confuse these two things as the same. So we'll see what is the difference between them. Before we jump directly into expressions and equations or what these are, we need to understand few important things. One is variable, the other thing is constant, the third thing is term. Right, so variable we have already discussed is something that we don't know. Right, so taking the example, so I'm saying think of a number. Right, I don't know what number you are going to think of. So that is a variable for me. Right, and I say that whatever number you choose, I'll multiply that with 5. So I know this 5, right? I'm aware of this number 5. So 5 is something that is not going to change. X is something that is going to change based on your mood. So if you want to choose a higher number, you can pick X as 9. If you want to pick a smaller number, you can pick X as 0. Right? So this is going to change based on mood, your mood, but the number that I'm going to multiply the number that you have chosen is going to be the same. Right? Is there any doubt in this? Any question? Okay, I'll assume no question. So this x or variable, so we can have multiple letters for variables. So represents something which is not known and is subject to change. For example, the example of rectangle that we discussed. So you can have a rectangle like this. You can have a rectangle slightly longer, or you can have a rectangle slightly smaller. So the length and breadth changes for each of these things. So that is why length and breadth is a variable, right? But say what does not change? This 2. So 2 times length plus breadth. So this 2 remains as it is, no matter how longer or how smaller the rectangle is. So this 2 is a constant and this L and B are variables. So variables are something that changes. Constant is something that remains the same. Okay, so you can use multiple letters. So any letter that you have in the alphabet, you can use that to represent a variable. Constants, you can use numbers to represent constants. For example, 5x. So if you take 5x as a number, right? So 5 is a constant, x is a variable, because x can be 1, x can be 2, x can be 3, x can be anything, but 5 would be 5 itself. So that is what you mean by constant. Constant means value that does not change. Okay. And if you combine variable and constant together, it becomes a term. So for example, 5 5 is a constant, so it is a term as well. X is a variable, x is a term as well. If you combine both of them, you'll get 5x. So 5x is also a term. So variables are term, constant are also term, and combination of constant and variable are also term. So that is what it is saying. So terms contain everything, be it variable, constant, or their combination. Combination can be if you divide it or multiply it. For example, you can write this as x upon 5. So this is division, or you can multiply them like 5x. So these are all examples of terms. Okay. Say y. Is y a constant or a variable or a term?
Sir, y is a variable.
Yeah, y is a variable, and because y is a variable, it is also a term, right? So what does term comprise of? Term can either be constant, term can either be variable, or term can be a combination of both.
Because that is one y, it will be one.
Yeah, right. Very good. So because it will be 1y, so that is why it is also a term. Okay, so when we are talking about terms, so there are two types of terms, like term and unlike term. So like term means the term that are the same or they contain the same variable. For example, if you look at this 2x and 19x. So 2x is also a term, 19x is also a term because they are combination of constant and variable, right? And 19x is also a term because it is also a combination of 19 and x. So 19 is a constant and x is a variable, right? So because both of them have the same variable x, that is why it is a like term. Okay. Unlike terms are the terms that does not have the same variable. So you have 2x and you have 19a. So one variable is x here and another variable is a here. So that is why, since the variables are not the same, that is why they are unlike terms, right? So this is similar to like fractions and unlike fractions. So like fractions were the fractions wherein the denominator are the same, whereas unlike fractions are the fractions wherein the denominator are different, right? Similarly, like terms are the terms wherein the variables are same, and unlike terms are the terms wherein the variables are different, right? So like terms, I mean, you can simply perform operations on like terms like addition or subtraction. How do you add like terms?
Can add it directly like 2 plus 90.
Yeah, so we just add the coefficients, right? So these are known as coefficients or constant terms. You can just add this constant term, right? So you'll get 21x, right? Can we add unlike terms?
No.
No, we cannot, because the variables are different, so that is why we cannot add or subtract them, right? Another question, we have 4w minus 10w, right? So these are also like terms because they have the same variables, w and w. So the variables are the same. So how to subtract them? So we just subtract the constant terms. So 4 minus 10 is minus 6, right? So we have minus 6 here, and then we just write the variable. So we'll write w. Okay, so this is how we solve like terms or perform addition or subtraction on like terms. I mean, since once we know about all the terms, right, then we can define what algebraic expression means, right? So algebraic expression means combination of terms, right? So it can be combination of variables, numbers, and operations. So if you combine two or more terms, we just discussed that, say for example, 2x. 2x is a term and 4y is also a term, right? So if we just combine 2x and 4y, it will become an algebraic expression, right? So it is a combination of variables, numbers, and operations. So this is also an algebraic expression because it is just a single term. So it can be one or more than one term. Okay, this y is a variable and 9 is a constant. So since it is a variable, it is also a term. It is a constant, it is also a term. So if you add both of them, so you are adding two or more terms or you are combining two or more terms. So that is why it is an algebraic expression, right? So this is a single expression, single algebraic expression, and this is a combination of two terms. So that is why it is also an algebraic expression. So you can either have one term, you can either have more than one term. So when you combine or when you have one or more than one term, it is known as an algebraic expression. Okay, and I mean, what is the difference between algebraic expression and algebraic equation? Can anyone tell me?
Expression has some terms means like multiplied together, whereas an equation has many expressions in it.
Okay, so see, algebraic expression, for example, 8 plus r is an algebraic expression, right? So this add two terms, so 2x plus 3y. This is an algebraic expression. But when you add an equal sign, so that is why you have equation. Equation means you have some sign, equal sign. So when you add an equal sign, say for example equals to 3, so this becomes an equation. Is this clear? So all the examples that we have seen previously, so these are expressions. These are all expressions. Now if I just add an equal sign, for example, this is equal to 5, or this is equal to 0, or this is equal to 7. So they all become algebraic equation. So they are no longer expression, they are equation now. Okay, so the only difference between expression and an equation is you have an equal sign in equation, whereas you don't have any equal sign in algebraic expression. Okay, so you solve algebraic equation, you don't solve algebraic expression. So if I give you 9 or m plus 3 equals to 5, then only you'll be able to solve it. So this means 3 plus some number gives you 5. So what is the value of that number? Yeah, very good. So the value of m would be 2, right? So I mean, if this was an algebraic expression, would you be able to solve or find the value of m? Because what does algebraic expression mean? So it would be limited to m plus 3 only, right? You won't have this equal to sign. So if I just say m plus 3 or 3 plus a number, do you know what the number is? 3 is a constant here. But I mean, would you be able to find the value of m using this? If I just give you m plus 3, right? If I just give you m, okay. So if I just write m plus 3, right? Would you be able to find the value of m? No, right? But when I say, so this is an algebraic expression. So you cannot solve an algebraic expression. You can only simplify it. So if I give you m plus m plus 3, you will be able to simplify it. Simplify means to make it simpler. Currently it has a lot of terms. So if you simplify it, it will become, so m plus m. What is the value of m plus m? So m and m both are like terms, right? So how do you add like terms? You just add the constant terms. Since it does not have any constant term, you'll just write 1 and you'll just write 1 here. So m plus m will become 1 plus 1 is 2, right? So 2m plus 3. So you can simplify an algebraic expression, but if I just give you m plus 3 equals to 5, then you can say m is equal to 2. Right, so this is an equation, this is an expression. So you can simplify an expression, you can solve an equation. Okay, any question? Okay. So see, this is the difference between an algebraic expression and an algebraic equation. So we cannot solve it, but we can simplify it. So this is an algebraic expression. So x plus 6. So you are able to write it as 2x plus 6. Right. Algebraic equation, on the other hand, you can solve it because you know it is equal to something. So for example, it is given 8 plus r is 17. Right, so you can solve the value of r as 17 minus 8, which is 9. So here you won't be able to get the value of that variable. Here you'll be able to get the value. Okay, so we have a question. I mean, can anyone tell me the answer to this question? I hope this is visible to everyone.
Sir, the answer is option A.
Okay. Anyone else is able to get option A as the answer? See, for those who are not able to get, so you'll just write the terms like this. So you'll just have to identify like terms. For example, x cube. So this is x to the power 3 and you have 4x cube. Right, so these two are like terms. So you'll just add the like terms. So 4 plus 1 will give you 5. So you'll have 5x cube. And then you have another like term minus 3 and 10x square. So these two are like terms as well. So you'll write 10 minus 3, which is 7. Third, you have minus 6x and plus 15x. So they are like terms as well. So you'll write 9x, because if you write 15 minus 6, that will be equal to 9. And then finally you have plus 10 and minus 20. Both are constant terms, so they are also like terms. So you'll write as minus 10. Okay, so this was an algebraic expression. So we added two expressions. Now we'll solve an equation. Okay, can anyone solve this and let me know the answer?
Sir, answer is A.
Yeah, very good. So what do we do here? We do cross multiplication, right? So 4 becomes 12 and we have 2x minus 5 is equal to 12. And then we take this to the right hand side. So this will become minus 5 will become plus 5. So 2x is equal to 17, or x is equal to 17 upon 2. Now, I mean, we have already discussed some of the components. So two major components are there in an algebraic expression. One is a variable, the other is a coefficient, right? So algebraic expression, first of all, it is a combination of terms, right? And term is a combination of constant and variables. So 2x, 2 is a constant, x is a variable, right? So I have just combined 2 and x, so it became a term. And then if I combine two terms, so 5 is also a term, it is just a constant, it becomes an algebraic expression. So when you have an algebraic expression, you have two components. The first component is a variable, the other component is a coefficient. Right? Say if I give you 5x, x is a variable and the factor of x is a coefficient. Right? So you have a number, say 6. What are the factors of 6? So prime factorization of 6 will give you three factors, right? 1, 2 and 3. So these are the prime factors of 6, right? 1 is although not a prime factor. If you do the factorization, so you'll get 2 and 3 as the factors of 6. Similarly, if you do the factorization of 5x, you'll get two factors, 5 and x. So 5 and x are the factors of 5x. Okay, so if you have an algebraic expression, say 5x square, here again the variable is x square and the coefficient is 5. Okay, so you can have multiple algebraic expressions. So, and then in that algebraic expression, you may be given to find the coefficient. So we have a question here. So you have 9x plus 8. Can anyone tell me what is the variable? Yeah, x is the variable, right? 9 and 8 are the constant terms, right? So x is the variable and 9 and 8 are the constant terms. So now the next question can be, what is the coefficient of x? So coefficient of x would be mean what is multiplied to x, right? So if you just to find the coefficient, just remove the variable from it. So if you just remove it, you'll be left with 9. So that means 9 is the coefficient of x. Okay. So for example, if you have numbers like this, x, and if I ask what is the coefficient of x, you'll see nothing is multiplied to x, but I can write x as 1 times x. So then 1 is multiplied to x. For this case, the coefficient of x is 1. And for this case, if I ask what is the coefficient of q, so what is the coefficient of q? Yeah, it is 96. So you just have to hide the variable term and then you'll get the coefficient. Okay. Now, this is a question. Jam places n numbers of oranges in two large boxes. Right. What is the total number of oranges you'll have? So say for example, this is the first jar, you placed n oranges here. This is the second jar, you placed n oranges here. So what is the total number of oranges that you have? Yeah, very good. It is 2n, right? So in 2n, what is the constant and what is the variable? Yeah, variable is n and constant is 2, right? So we can also say n is a variable and the coefficient of n is 2, right? So you can see we have the total number of oranges will be 2n, the variable is n and the coefficient is 2, right? Next we have this question, what is the coefficient of x in this equation? Yeah, very good, it is 4, right? So we have terms like this, 3x square, 4x, 1. So these are three separate terms, right? But we are asked to find the coefficient of x. So we are not asked to find the coefficient of x square. So we'll only look at this particular term which has x in it, not x square. We'll just look at this. So, and to find the coefficient, we just have to eliminate the variable term. So we'll get 4. So 4 will be the answer, right? Okay, so whenever we have algebraic expressions, so they are usually of three types: monomial, binomial, and trinomial. Monomial has one term, binomial has two terms, and trinomial has three terms. We also have polynomials. Polynomials have two or more than two terms. Okay, so anything that has more than one term, any algebraic expression that has more than one term is known as a polynomial, right? So you have monomial, which is one term, and then example of monomial is 5x square. So here x square is the variable and the coefficient of x square is 5. Binomial, it has two terms, for example 5x square minus 8x. Here x square is the variable, the coefficient of x square is 5, x is another variable, the coefficient of x is 8, right? I mean, they are the same variables, x and x square, but they have different forms, right? Trinomial has three terms. So the coefficient of x square is 5, the coefficient of x is 8, and 1 is the constant term. Additionally, you also have degree of a polynomial. So what we saw in the previous terms are the different forms, right? So for example, you have 5x square minus 8x. So they have the same variable, but they are of different forms. We also call that they have different degrees. So the degree is basically the power of the term. So for example, the variable term. So you have x here, so the power of x is 1. You have x square here, so the power of x is 2. So the degree of x here is 1, the degree of x here is 2, right? And when you have multiple terms, the entire polynomial will have a single degree, right? So for example, if you just look at this term, so degree looks at the highest power. So the highest power here is 1. So that is why the degree is 1. Here, if you look at this entire polynomial, the highest power is, what is the highest power in this polynomial? Is it 1 or 2? Yeah, the highest power is 2. So that is why the degree is 2. Here you can see the highest power is 3. So that is why the degree is 3. Here, I mean, why is the degree 5? For this polynomial, why the degree is 5 and not 4? So if in a single term, right, if in a single term you have two or more variables, you just add the power to get the degree. So here you had two variables x and y. The power of x was 2 and the power of y was 3. So you just add the powers. So 3 plus 2 is 5. So that is why the degree is 5. Okay. So if you have x square y to the power 7, what is the degree of this term? Will it be 7? Will it be 2 or will it be 9? Yeah. It will be 9 because it, right, even if we have same powers, for example, x to the power 4, y to the power 4. So we just add the powers. So this will be, the degree will be 8. Yeah. Then we have some basic operations. For example, addition, right? So you may be given word problems and then you have to identify the algebraic expression. So that is how you write algebraic expression. So if you are given 4 more than x, so this more is the keyword using which you can identify that you have to add. So 4 means the number 4 or the constant term 4, and more means plus, and then x means the variable x, right? So this becomes x plus 4 or 4 plus x. Then you have 4 less than x, right? It is not x less than 4, it is 4 less than x. So take any number and then subtract 4 from it. So this less helps you understand that you have to subtract. Okay, so this will be x minus 4, not 4 minus x, because it is saying that subtract 4 from x, right? That is why it is x minus 4. Then you have quotient. Quotient means you have to divide, right? So the quotient of x and 4. So divide x by 4. So you'll get x upon 4. So this is, the quotient is used to identify division. And then you have product. So product of x and 4. So this will be 4x. Okay. I mean, we have these 4 questions. So the first question says the sum of u and 11. So what will be the algebraic expression for this? Yeah, very good. So it will be u plus 11. 8 more than 5x. Yeah, 5x plus 8. Then you have 8 more than the quotient of 9 and x. Yeah. So usually the pattern is that when you write quotient of 9 and x, it becomes x upon 9, right? And then you just have to add 8. So 8 plus x upon 9. Okay. And then you have 3 less than xy. 8y, sorry. 3 less than 8y. Yeah. So first comes 8y because you have to subtract 3 from 8y because that number is 3 less than 8y. Okay. What is square of x plus 4 times y? Which of the following options correspond to this? Yeah. So you have square of x, so that becomes x square. 4 times y, yeah. 5 times x minus 2 times y. Okay. Kanmani, I hope you are following. If you have any questions, you can maybe, if you are not willing to speak, you can just type it in the chat box. Which one of the following is the equation for the statement given below? Half of the number x subtracted from 20 is 15. Yeah. Again, this pattern is opposite. Half of a number x. So this becomes x upon 2. Subtracted from 20. So 20 is a constant term. So you are subtracting x upon 2 from 20, right? Not 20 from x upon 2. So that is why this is C. Yeah, very good, Aradhya. Okay. Kanmani, are you able to follow? You can just let me know yes or no. Okay, first of all, tell me what is the degree of this polynomial? Okay, 5. See, the degree will be 5 when these two terms are multiplied. So when you have x cube times y square, then the degree will be 5. But since they are added together, they are two separate terms. and the degree are separate. Okay, so the degree here will be 3 only, not 5. Is this clear, Aradhya? Why? Okay, so you have x cube plus y square because they are separated by plus, right? So that is why the degree is 3 only. Because, so plus actually separates them into two different terms. Multiplication does not separate them into different terms. Okay, so now, is this a monomial, is this a binomial, is this a trinomial, or is this a polynomial? Yeah, it is a binomial and it is also a polynomial because polynomial contains two or more than two terms, or anything that contains more than one term is a polynomial. If you have one term, it is a monomial. If you have two terms, it is a binomial, three, trinomial. And then polynomial is used to categorize everything that we either be it binomial, be it trinomial, and so on. Now, I mean, you have to just substitute the value. So you are given an algebraic expression, right? So you have to find the value when the values of x and y are given. So for such questions, just substitute the values. So instead of x, just plug in 2. Instead of y, just plug in 5. Right? Can you tell me what will be the answer for this question if you just plug in the values? So say instead of x, I'll just substitute 2. So this becomes 2 to the power 3. Right? What is 2 to the power 3? So 2 to the power 3 means nothing but just multiply 2 3 times. So I'll get 2 to the 4, 4 to the 8. Right? So this will become 8. And y square. So instead of y, we just have to substitute 5 because it is saying x equals to 2. So instead of x, I substituted 2. And instead of y, it is saying substitute 5. So instead of y, I substitute 5. So 5 square. 5 square, just like 2 cube meant 2 times 2 times 2. 5 square means multiply 5 with itself 2 times. So this will become 5 into 5, which is 25. Right? So you can just add both the two numbers. My pen is not working today. So you have 25 plus 8, which is 33. So D is the correct. Okay. Similarly, try finding the value of this. So you have three variables A, B, and C. You are given the value of A, you are given the value of B, and you are given the value of C. Okay. See, A, the value of A is given as 4. So what do? Instead of A, just substitute 4. So you'll get 4 square. So what is the value of 4 square? 4 square means 4 times 4. Right, so this is 16. The value of B is 5. So 16 minus 5. So this is the numerator. So 16 minus 5 is 11. Right, and then what is the value of C? C is given as 8. So 2 times C. So 2 times 8 is 16. So you'll get 11 upon 16, which is the answer. Okay, yeah, I guess Aradhya already had the answer. Right, any doubts? Kanmani, you have any doubt?
No, it's all clear.
Okay. If 4 times a number is 56, right, then find the number. This is the final question for today. So this is a statement type question wherein you are given a statement. So there are two tasks to do. First of all, find the algebraic expression using this, convert this to equation using this, and then find or solve the equation. Yeah, very good, Aradhya. So 4 times of a number. So this is the algebraic expression. Right, 4 times of a number means let the number be x. Right, let the number be x. So 4 times that number will become 4x. So this is the algebraic expression. So if 4 times a number is 56, it is saying 4x is equal to 56. Find the number. So what will be the value of x? X will be 56 upon 4. Because you divide both sides by 4, so this will become x and this will become 56 upon 4. And 56 upon 4 is equal to 14. So the answer will be 14. Okay. Yeah, fine. I mean, these are all the questions I had for today. Maybe we'll start a new topic tomorrow or maybe next week. That is all from my side. I think we can close the class. Thank you.
Thank you so much.
Yeah, welcome.